We're all living through this incredible AI revolution, right? It's everywhere, from generating text and images to helping drive our cars. But as these systems get more and more powerful, more autonomous, we have to ask a pretty big question. How can we actually trust them? Well, it turns out the answer might be hiding in the oldest and most solid language we've got, mathematics.
Okay, so let's get into it. Our guide for this is an expert analysis that comes straight out of the University of Oxford, and it lays out a really fascinating case for where AI is headed next.
And that's no exaggeration, is it? We're all getting used to these systems. Some are these incredible analytical engines, finding patterns in just massive piles of data. And others are generative. Think about all the large language models and media tools that have just exploded in popularity. They handle so many tasks, and that's great. It frees us up to focus on what really matters. But, and this is a big but, here's the catch. As AI starts moving from just, say, making recommendations to making decisions all on its own, the fact that we can't really see how it thinks, well, that becomes a huge problem.
So that brings us to our first big idea here, the hidden dangers that are lurking inside all of this incredible power that AI has. And what does that black box idea even mean? Well, it means that even when an AI gives us what seems like the right answer, we often have zero idea how it got there. Its internal logic is a complete mystery, just this super complex web of calculations that, for a human, is basically impossible to pull apart or explain.
And let's be clear, these aren't just little bugs we can patch later. These are some deep, foundational flaws. We're talking about systems that have hidden biases that they've learned from their training data, systems that can be tricked by bad actors, and, of course, systems that famously hallucinate. They just make stuff up. Without a real formal way to trust them, how can we ever rely on them for anything truly important?
So okay, how do we fix this whole mess? A common idea you hear is, let's just apply some math after the fact to check the AI's work. But honestly, that whole approach is built on a complete myth.
This right here is the core myth. It's this idea that you can build a black box AI and then kind of after the fact, use math as a tool to try and interpret it or check for errors. It treats math like an accessory, like some kind of diagnostic tool you run at the very end. But that approach just misses the entire point.
And this comparison really shows you the paradigm shift we need. The old way, the myth, sees math as a patch-up job. But the reality is that math needs to be the scaffolding the entire system is built on from day one. It's not for checking errors later, it's for building in stability from the very start. It's not for trying to interpret a mystery, it's for creating a system that is understandable by its very design.
So let's actually explore what this looks like. How do you build a better AI this way? Because when math is the foundation, absolutely everything changes.
This is basically the toolkit. First up, you've got probability and geometry. These help us actually understand the data itself, its shape, its hidden structures. Then you use optimization and analysis to make sure the AI learns in a stable, predictable way. Next, information theory helps us get real about what the AI can and, just as importantly, cannot figure out from the data it has. And finally, logic gives us the actual language to prove the AI will behave the way we expect it to.
This is the ultimate goal. AI that is interpretable by design. Just imagine a medical AI that doesn't just give you a diagnosis. Imagine it can also provide a mathematical proof that its conclusion is correct within certain boundaries, and that it isn't just based on some flawed correlation it found. That is a whole different world from just crossing your fingers and hoping a black box got it right.
At the end of the day, this isn't just about numbers. Math gives us something really unique. It gives us a language for guarantees. And that means when something does go wrong with an AI built on this foundation, we can understand exactly how and why, and then we can actually fix it.
So what does this future really look like? This is where it gets exciting, because we're not just talking about making today's AI a little bit safer, we're talking about unlocking a completely new generation of intelligence. Right now, today's AI is fundamentally about pattern matching, right? It's incredible at finding correlations in data. But the next giant leap is to build systems that can truly reason, that can adapt to brand new situations, and most importantly, can justify their actions within limits we understand.
Building on this mathematical foundation opens up some just incredible possibilities. We're talking about new types of brain-inspired computing, AIs that can actually handle genuine abstraction, maybe even show a kind of creativity. It all boils down to this. We're moving away from blind trust in a black box and toward what you could call warranted confidence in a transparent system.
What this all means is that math isn't just going to be supporting the next phase of AI, it's going to be leading it. It's going to be the source of the new ideas that innovate and completely disrupt the field, pushing us way beyond what we even think is possible right now.
So, here's the thought to leave with. We already use AI every single day. That's a given. But to build a future where we can truly rely on it for our most critical decisions, in medicine, in science, in our society, we might just need to build it on a foundation of mathematical truth. The real question isn't just about making AI smarter, it's about making it provably, demonstrably trustworthy.